Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of direct variation. This is standard A.2D in the great state of Texas, and we are using item number 27 of the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So, we know we need to use direct variation because look at this problem. It says the value of y is directly proportional. So sometimes it will give you something as clearly as that, directly proportional. Sometimes it might give you a problem that says varies directly. Either way, when you're seeing that word direct or directly, that lets you know that we are dealing with direct variation, y equals kx. And this might look kind of like our slope-intercept form. It's meant to look similar, right? So our slope-intercept form is y equals mx plus b. So our direct variation is y equals kx. So the k and the m, right, they both represent our rate of change. And we usually just call them our slope. So they're both that same thing, that slope. The only difference is you notice the y equals kx does not have a slope, a y-intercept there to kind of affect the slope, to move it off of the origin. So when we are graphing our direct variation, it's always going to go through the origin, whereas the slope-intercept form usually doesn't, and because that plus b is going to knock it off. Going to move it up, down, left, right, whatever. So we need to find y when x is 70. Okay, so if y equals kx, we need to find our constant of proportionality, and they used to give that to us on our mathematics charts in 7th grade and maybe even 8th grade. We can derive it pretty easily. Just divide both sides by x. We've isolated the k. So k is our constant, our slope. So k equals y over x. So they give you 2 right here. All right, so let's see what this is going to be here. So I've got y is 35, x is 140. Remember, it's rise over run, okay? And actually, if you divide both sides by 35, or divide top and bottom by 35, take a look at that. So 35 doubled is 70, and 70 doubled is 140. So I doubled a double, that means it's going to be 1/4. So there we go. Our k is either going to be 1/4, or you might prefer to see it as a decimal, 0.25. So that's our constant of proportionality. Now, all we need to do is plug that back into our original y equals kx. So y equals kx. I'm looking for the value of y, so my x is 70, so it's just going to be y equals, I'm going to stick with this right here, the 1/4. You could do 0.25 if you want to. And then my x is 70. All right, so that's going to be 70 over 4. All right, so if we want to bring it down a little bit more, 35 over 2, which is going to be 17 and 1/2. Now, we do have to bring it into the decimal form because it is a free response. And so, griddable response there. On the STAAR test, paper STAAR test, you would get these 7 columns here, and it's called a floating decimal point. You'd have a positive and negative symbol over here, and then you would have a decimal point that could be in any of these spots. And then underneath that, your 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the digits. So you could put that 17.5 anywhere you wanted to, as long as you used the decimal correctly. Now, it doesn't hurt to always move things over to the right, so you could put it right there. As long as you bubble in the 17.5 with that bubbling in that decimal, that would work. You also could have done it right here, over on the far left, and it also would have counted correctly as long as you used that decimal correctly. 17.5 is your answer.